In section 3.2, we're going to use all of the derivative rules that we used in section 3.1, except for in today's lesson, we're going to be talking about how to take the derivative when you've got two different functions being multiplied or two different functions being divided. So to start with, we've got the product rule. And right here, we've got specifically two different functions. We're going to call it the first function and then the second function. The product rule tells us that we're going to take the derivative of the first function times the second function plus the derivative of the second function multiplied by the first function. Because of the addition sign right here, it does not matter the order that you take the derivative and multiply it by the other one, as long as you do both of them. So we're going to take the derivative of f and multiply it by g plus the derivative of g and multiply it by f. That's product rule. For quotient rule, you've got a numerator and then you've got the denominator. With the quotient rule, you're going to take the derivative of the numerator and multiply it by the denominator, minus, which means that the order matters, the derivative of the denominator multiplied by the numerator all over your denominator squared. So for this function, we're going to take the derivative of f, multiply it by g, minus the derivative of the denominator, which is g, multiply it by f, all over the denominator squared. And these are two very specific rules that need to be memorized. So in the first two problems, we're going to use this graph of f and g. And in the first problem, we're going to find f prime of 1. Well, if you were to input the value 1 in here, you'd get two numbers multiplied together. You can't take the derivative of that. It'd be 0. So the first thing you have to do is find the derivative of h. So once again, you have your first and then your second function. So we're going to start by taking the derivative of the first function. So you've got f prime of x multiplied by the second plus the derivative of the second, which is g prime of x, and then you're going to multiply it by the first. So make sure that you are very particular in which one your first and your second is. After that, we're going to input 1. So we're going to find h prime of 1. So we've got f prime of 1 times g of 1 plus g prime of 1 times f of 1. Now, in the first one, we've got f prime of 1. Anytime you have a derivative, you're always talking about the slope. So we can go ahead and find the slope of the function called f, and the reason why I highlighted that is because that's where 1 falls. 1 is right here. 1 falls in that, so I want the slope of that line, so up to right 1, so the slope is 2. And then we have to evaluate g of 1. Well, g of 1 on the other line happens to be at 1, 2, it looks like we're at 3. Plus, the next thing that we have to do is find g prime of 1. So now I need that line's slope because the derivative means slope. It looks like we're going down 1, right 1, down 1, right 1. So we've got -1 and then multiplied by f of 1. So evaluate the function of the graph of f, which is this line at 1, 2. It looks like we're at 3. So we've got 6 minus 3, which equals 3 as our final answer. In question 2, this is, so we're going to go ahead and find k prime of x before we plug in the number. Do not plug in the number first. So we're going to take the derivative of the numerator multiplied by the denominator minus the derivative of the denominator multiplied by the numerator all over your denominator squared. From here, we're going to go ahead and evaluate k prime of 6. So we've got to input the 6 everywhere that we see an x. This is a little bit tricky because right now we're going to find f prime of 6. So I'm going to go 1, 2, 3, 4, 5, 6, and then we have to go to the function called f. F is the skinnier line. So we need that slope. And it looks like that slope is down 1, right 2, so we're at -1/2. And then after that, we have to find g of 6. So to find g of 6, I'm going to go to the line called g, 1, 2, 3, 4, 5, 6, and up to the line, and it looks like we're at the number 2. And then it's minus g prime of 6. So let's go ahead and figure out where that is. Now, g is the thicker line, and I need that line's slope. So it looks like we're down 2 right 1, so that's going to be negative 2 over 1. And then we have to multiply it by f of 6. And that's the skinnier line, and it looks like we're at 1, 2, 3, 4. So I'm going to multiply it by 4, and then all over g of 6, which is 2, that we have to square. And it looks like our answer is going to be negative 1 plus 8 divided by 4, which is 7 over 4 is our final answer. So again, derivative is slope. And then when you're evaluating the function, just look for the point, the ordered pair. For question number 3, it asks us to find f prime of 2. And we've got the function called f right here, and it looks like g is the first one, and then h is my second one. This is multiplication, which means that in order to take a derivative, we're going to use the product rule. So we're going to take the derivative of the first times the second plus the derivative of the second times the first. Then you get to evaluate f prime of 2. So we've got g prime of 2. And then after we input the values, we're simply just looking for what the numbers are. So g prime of 2, the problem told us the answer is negative 4. H of 2, the problem told us it was negative 1. H prime of 2, the problem told us that it was 5. And then g of 2, we're told the answer is 3. And we get 19 as our final answer. For problems 4 and 5, we're going to find the derivative by using product rule. So we have our first function, and then you've got your second function. So you're going to take the derivative of the first multiplied by the second plus the derivative of the second multiplied by the first. And you can leave your answer just like this. Now, it's key that when you get to number 5 and you're looking like at y, please don't get mixed up on like what the notation is. Use whatever notation that you feel comfortable with. With y, I use dy over dx or y prime. It's just interchangeable. Number 5 is a good problem to pause the video and make sure that you have understanding by yourself. In number 6, once again, this is 2 functions because we've got a linear function and then multiplied by exponential. So when we find the derivative of this, we're going to take the derivative of the first one multiplied by the second, which is e to the x, plus the derivative of the second one. Now, the derivative of e to the x happens to just be e to the x, and then we're going to go ahead and multiply it by the x plus 2, the second one. In number 7, and number 8, these are just different notations, and it just tells you to evaluate the function at 1 after you're done. So both in 7 and 8, you are going to find the derivative and then input the value of 1. In both of these problems, you are using product rule. So number 7, I have done for you. Number 8 is a great one to do, though, because it uses one of the rules for derivatives, which you have to bring the denominator, which has the x, up to the numerator by making the exponent negative. So the derivative of this problem, you're going to take the derivative of the first, which is x plus 1 over x. So the derivative of x is 1. The derivative of x to the negative 1, multiply to the front, and then subtract 1. So there's the derivative of x to the negative 1. And then you multiply it by exactly what the second is. Plus, and then you're going to take the derivative of the second. So we've got 42x to the 6th minus 20x to the 4th. And then the derivative of that's negative 3x to the negative 2. multiply it to the front, it's going to become positive 6x, and then subtract 1 and you get negative 3. From there, I'm going to use the specific notation that it wants. So we've got dy over dx evaluated at x equals 1, and you're going to plug in the 1 and get your final answer. So our final answer ends up being 56. Numbers 9, 10, even 11, they are all involving quotient rule. So for quotient rule, it is a huge pain, but I did some easier problems. Number 9, we're going to take the derivative of the numerator multiplied by the denominator minus the derivative of the denominator multiplied by the numerator all over your denominator squared. The only thing that you could potentially do is mess around with your numerator and multiply it through and then simplify. 3 times 2x, that's going to be 6x. 6x minus 6x, it's going to become 0. So you've got really just the 3 times the 1, 3. 3 over 2x plus 1 quantity squared. That would be the only thing that you could possibly do. But you can leave your answer totally unsimplified. For number 10, again, quotient rule, you're going to take the derivative of the numerator, and you need to make sure that 2x minus 2 stays together because you're about to multiply it by the denominator, which is the binomial, minus the derivative of the denominator multiplied by the numerator, all over a total rewrite of the denominator squared. From here, you can input the negative 1 and get your final answer. And then you get your final answer, which is 8/25. Question number 11. That's another great question. So we've got f of x equals 6x divided by a plus x cubed. Every single time that you have a constant called a, b, c, if you've got a letter right there, a, b, c, it's really talking about a number. So what they want you to do is wherever a prime is of 0 equals 3, they want you to find a. So you're going to have to use quotient rule, f prime of x, and you're going to take the derivative of the numerator, which is 6, multiplied by the denominator, a plus x cubed, minus the derivative of the denominator. A is a constant. It represents a number. So when you take the derivative of a plus x 3x cubed, you're going to get 3x squared, and then multiplied by the numerator. All over your denominator, which is a plus x cubed squared. So from there, what you're going to do is you're going to, anywhere you see an x, plug in 0, and then you're going to replace y with 3. So f prime of 0 is 3, so f prime of 0 right there, 3 equals, and you're going to, anywhere you see a x, plug in 0. So really, you have 3 equals 6a divided by a squared equals 3. So I can cancel out an a in the numerator with an a in the denominator. So we've got a times 3. So therefore, a can only be the number 2. After that, we've just got some rules. So it's just going through the different rules for derivatives. So we're going to take the derivative of u over v. So we've got the derivative of the numerator times the denominator minus derivative of the denominator times the numerator all over the denominator squared. And then we can evaluate it at 4. So it tells us that u prime of 4 is 2 multiplied by v of 4, which is 1, minus v prime of 4 multiplied by u of 4 all over v of 4 squared, and we have our answer, which is really just 2 minus 12 over 1, which is negative 10. In this next one, we are going to use product rule, take the derivative of u multiplied by v, and then evaluate it at 4. So we've got the derivative of the first times the second plus the derivative of the second times the first, and then we're going to input 4. And for that one, you get a final answer of 14. When we take the derivative of 2u minus 3v, this is an old rule, drop down the constant and take the derivative of each separately, and we get negative 8. And then we end again with quotient rule. Last but not least, position to velocity is a derivative. Initial means